So once we've done that, so putting in our parameters, then from there we can calculate whatever statistics we want. So in this case, I've asked for mean and standard deviation. So if we go calc, and again, it's one variable, list 1, all the data's in list 1, frequency of 1. And from here, for my data, there's my mean and standard deviation. So yours will be different, slightly, but notice I set up a distribution such that I have a mean of 58 and a standard deviation of 14. So you would expect that in your sample that you selected, you would get around about that same mean and standard deviation. It's not going to be perfect. Remember, there's variations in the sample, but it would be around about that figure. So I think the data, this is generating, again, the same thing. So we're doing this 50 times, and you can see what the graph might look like. So if we increase the sample size, then that's what the theoretical distribution might look like, and this is what it is with a sample size of 500. So it's certainly a better match. Still not perfect. And remember, it is continuous data that we're trying to package into columns, so just remember about that too. But really, it is kind of similar to what we would expect. And so the moral of the story is, the higher the sample size, the better the sample reflects the population, which kind of makes sense. We don't want too low a sample size, otherwise we're not going to get necessarily a group that is reflective of the population or what the population might look like. So with the next question, if you work in pairs, one of you can do set A, one of you can do set B. That way you're not both doing two sets because it gets a bit tedious. So from what I can see here, so here you have two different samples, both with the same number of observations, and here we have two different means and two different standard deviations. It is taken from a data set that has a mean of 50 and standard deviation of 8. So you can see there are differences, certainly. And then when we graph the data, so we're graphing in with interval widths of 5. Remember, this is normal distribution. So in order for us to graph this effectively, we do need to have group data that is grouped. And so you can see here, again, it's that kind of simple type of scenario where it follows that kind of normal curve. And in part C, let's assume we've all done this. In part C, it suggests that we want to look at 250 observations. So let's put 250 in our calculator. It's the 8 first. It's always the standard deviation first. So I think I need to go back here to the keyboard, probably easier. Rand norm. Whoops. And then, yes, we put the standard deviation first, then the mean, and then the number we want. Don't know why I'm putting spaces here. The equals is not right, so used to a spreadsheet. So list 2 is where I put my data, and again it's just calculating the stats. Now I've got to go to list 2. Okay, and mean is pretty close to 50. Standard deviation is similar, closer probably to the actual standard deviation of 8. And if I want to draw a graph, it will, I'm going to start, yeah, that'll do. A step, if I do a step of 5, it's easier to compare. So that's it there. That's my data. Making sure that it is list 2 that I'm graphing. Histogram, list 2, though that's wrong. I was going to say. Change that to 5. That's better. All right, so there's list 2 that I'm graphing. That's what my graph looks like. You can see it's quite nice. I've got it almost symmetrical, not quite, but certainly starting to look like the features of a normal distribution. So, what is the point of all this stuff that we're doing? Well, one is to make sure that you can generate samples on your calculator. That's the first thing. And then from there, calculate any statistics that may be required. But then the second thing is just emphasising the fact that you've got samples aren't the same. Because unless you're selecting the exact same values, you're going to have variation, and really that's the point. However, we would expect that as the sample size increases, the statistics, and we usually look for mean and standard deviations, do get closer to the expected population mean and standard deviation. And as we increase the sample size, the shape gets closer to the shape of the population distribution, whatever that might be. So really that is kind of the point of what we've been asked to do in looking at variations within samples. Why this is important, as I mentioned earlier, is because the whole point of this is to start to make predictions about the population. If you don't have the population information, like how often would we know what the population mean, standard deviation, whatever the stats might be? And so the whole point of sampling is if you get a good sample representative of the population, we can use it to predict what the mean, standard deviation, or whatever those stats might be. Our focus, however, is on proportions, not means. So that's what we're going to lead into next.